I discovered a proof regarding a floor function result that I think is flawed. Maybe the proof's correct, but in my opinion, it's a little unclear. And I think whoever proved this assumed what they were trying to prove right in the middle of the proof. It's called circular reasoning. Now, again, I could be wrong, and my apologies. I'm not naming the prover. I mean, it looks like a nice proof, but I think there's a flaw in it. Now, so you guys remember the floor function just maps to the next lowest integer. Like, for example, the floor of 3.8 is 3 because it's the greatest integer less than 3.8. Now, this result here looks pretty natural. It says the floor of a real number plus an integer is just equal to the floor of the real number plus the integer. Now, it sounds like I said the same thing there, but what this first part says here, it says the floor of the quantity x plus b is equal to the floor of x plus b, and that is something different. It sounds the same, but it's different. Now, b is an integer, and x is assumed to be a real value number. Now, the way they start out the proof here looks just fine. They let x equal to its floor plus its fractional piece. All right, and notice what they call epsilon here is a number bounded below by 0 and above by 1 strictly. Okay, now, if you come along and follow the proof, they're marching along, it looks just fine. But if you take a look at what this says up here, they're assuming it going from here to here. And I hope you're following what I'm talking about. You have the floor of an object plus an integer. All right, that entire thing is wrapped in the floor notation, right? Then all of a sudden here, just the first part is wrapped in the floor notation. The integer appears on the outside, which is exactly what this says. So I maintain that it's not really a proof. Nowhere in the proof did they appeal to the fact that epsilon was less than 1. Now, I'd like to go down and show you what I perceive to be a correction to this proof. Now, I'm going to use the exact same letters and notation that the author of this proof did, but x equals to a plus epsilon implies that the floor of x is a, right? E is the integer part. A and b are understood to be integers here. They're stated up here. A and b are both understood to be integers. X is a real number that may have a fractional part, so we'll write x as a natural number, an integer plus epsilon. Now, just from the word get-go, that implies that the floor of x is 8. That's the definition of the floor. Okay, it's the next integer down, if you will. All right. Now, where I think this particular proof went wrong is the floor of x plus b, you can see, is equal to the floor of a plus b plus epsilon from what I've written right here. X is equal to a plus epsilon. So if you just think of putting a plus epsilon right here, and you get a plus b plus epsilon. But notice that a plus b is the integer portion of this expression. A is an integer, b is an integer, right? And so the floor of a plus b plus epsilon quantity is just a plus b. All right, but we just noted a while ago that the floor of x is a. So you see, we get the result without any ambiguity right here. The floor of x plus b is equal to the floor of the quantity x plus b, and that makes sense. If you're just chunking an integer in there, that stands to reason. But again, I think this proof was flawed, and if I'm wrong, that's the way it goes. But I read it carefully, and it didn't seem like they ever used the fact that epsilon was less than 1 anywhere in this proof. Now, and again, let me mark something here for you. I just want to make it clear. Going from this is probably the crucial step right here, but notice that this piece right here follows. All of this follows just from the greatest integer, what it means to be the greatest integer function. Okay, greatest integer function property. Okay, the greatest integer function literally takes the input of a real value, and it's going to return the next lowest integer. All right, it's the next lowest integer, which means the greatest integer less than the input argument. Well, that's clearly, if a plus b plus epsilon is the input argument, a and b are integers. The greatest integer function is going to return A plus B, right? But again, what wasn't recorded right up here is that the floor of X is equal to A. So I replaced A with what it's equal to, you see, and we got the result. Now, again, my apologies if I've overlooked something here, but again, it seems like there's been some circular reasoning done in this particular proof. Thanks for listening.